Welcome to this video on metals and nonmetals. We will explore their fundamental properties, the key differences between them, and how they react. Our world is made of many different materials. By understanding their characteristics, we can better utilize them in our daily lives. Metals are incredibly important. From the tools in our workshops, to the wires in our homes and the jewelry we wear, they are essential to modern society. One of the defining features of metals is their natural shine or luster. When polished, metals reflect light beautifully. Metals are also malleable. This property allows them to be hammered or rolled into thin sheets, which is useful for manufacturing and construction. Furthermore, metals are ductile. This means they can be drawn out into thin wires, a property that is vital for our electrical infrastructure. Another characteristic of metals is sonority. They produce a distinct ringing sound when struck, which is why bells are commonly made of metal. Metals are excellent conductors of heat. This is why metal pans are so effective for cooking. They transfer energy from the stove to your food efficiently. In addition to heat, metals are great conductors of electricity. Copper wires, for example, allow electrical current to flow safely and reliably. To summarize, metals are incredibly useful due to their luster, malleability, and ductility, making them versatile for many different applications. Their usefulness is further enhanced by their sonority and their ability to conduct both heat and electricity effectively. However, some metals can rust when exposed to certain environments, which can damage their appearance and structural integrity. Rusting is essentially a chemical reaction that requires both air and water. Keeping iron away from these elements prevents rust. We can protect iron from rusting by using methods like applying paint, oil, grease, or by using a zinc coating, a process known as galvanization. When metals react with oxygen, they form metal oxides. We can write this as metal plus oxygen produces metal oxide. Burning magnesium in air is a classic example of this, creating a bright flame and a white powder called magnesium oxide. This is an example of a metal reacting with oxygen. We have seen how metals behave, but metal oxides are also basic in nature. When wet water to magnesium oxide powder, the resulting solution turns red litmus paper blue. Beyond metals, nonmetals are also all around us. Common examples include sulfur, carbon in the form of coal or diamond, phosphorus, iodine, and gases like oxygen and nitrogen. Nonmetals serve vital roles in our daily lives, from oxygen for breathing and carbon for tree growth, to chlorine for water purification and iodine for medicine. Nonmetals also react with oxygen to form nonmetal oxides. For instance, burning sulfur in oxygen produces sulfur dioxide gas. In contrast to metal oxides, nonmetal oxides are acidic in nature. When sulfur dioxide is dissolved in water, it forms sulfurous acid. Phosphorus is stored underwater because it is a highly reactive nonmetal that can catch fire when exposed to air. There are many differences between metals and nonmetals. Metals are generally shiny, strong, malleable, ductile, produce a ringing sound, sonority, and are good conductors of heat and electricity. Nonmetals are usually dull, brittle, do not produce a ringing sound, and are poor conductors of heat and electricity. However, nature is full of exceptions. For example, mercury is the only metal that is liquid at room temperature. Other exceptions include graphite, a nonmetal that conducts electricity, and diamond, a nonmetal that is the hardest naturally occurring substance. Sodium is a metal so soft that it can be cut with a knife. Bromine is the only nonmetal that is liquid at room temperature. Iodine is a shiny nonmetal, which is unusual. Aluminium is lightweight, making it useful for aeroplanes. Human progress has always been tied to the materials we mastered. In the Bronze Age, the alloy of copper and tin gave rise to durable tools, weapons, and early trade networks. Alongside metals, nonmetals like iodine were already valued for healing wounds and antiseptic uses. Moving into the Iron Age, iron became the backbone of agriculture, construction, and warfare, transforming societies. At the same time, nitrogen as a non-metal revolutionized farming through fertilizers, boosting food supply and population growth. Then came the Industrial Revolution, where steel-powered railways, machinery, and urban expansion. Nonmetals like chlorine played a different but equally vital role, ensuring clean water and hygiene, sparking a public health revolution. In the modern era, metals like aluminum and titanium powered aviation, electronics, and renewable energy, while nonmetals such as carbon-fueled industries, filtration, and steelmaking. Entering the digital age, silicon and gold became the backbone of computing and communication, driving microchips and global connectivity. At the same time, graphite emerged as a key nonmetal for batteries, electronics, and even everyday writing tools. In the healthcare age, oxygen stands out as the most vital, non-metal, sustaining hospitals, life support systems, and respiratory therapy. reminding us that materials are not just about technology, but about life itself. Metals provide strength and progress, while non-metals sustain life and health. Together, they are the foundation of our world. Keep observing and exploring.